Hello everyone, I'm Etienne Clavry and I will show you the work I did for the big data final project for the DKIT. So what is that project? It's about creating a database which is showing the users of EMON-PI. It's a system which can record the electricity power and the temperature in a house. Also, there are tables about weather stations and reports of these stations. So I will show you all the tables I created for that project, and then we will discuss about few things about flexibility and scalability. So what are the tables? First, you can see there is a table about the stations, the weather stations here. This table, this table is showing all the weather stations in the database. As you can see, in this table you have an ID, which is a primary key, the name, like for example Dublin Airport, the age, the latitude and the longitude. Then, about all these stations, they can store their reports in the table reports. So in that table, we can see all the reports. These are just samples, but it's reports about the weather taken from the weather station. So you have the date and several informations about the weather. All these informations have keys and indicators that can be found in other tables, like for example rainfall indicators, temperature, wet bulb, wind direction, and wind speed, which are corresponding to several rows and columns here. So then we have a weather key. Where is it? A weather. Oh, a weather key here and a report key here, which are showing also several informations, like as you can see, describing all the data with what they are talking about and the unit used. Then in all the indicators you can find also several informations about the code used everywhere, because just read like that it doesn't make any sense, but with the indicators you can have like a real description of the weather. Then about the users of EMON-PI, they have also it looks like the table stations. It's the table users. I will show you. So here we can see that every user have an ID, a name and an email, and so the ID is also a primary key. Then in the tables power and temperature, what we can find are several informations about the power used in the house. You have the ID user, which is a foreign key to the table users. You have the date also showing the power at every minute. Then the user can find his own information because they are all related to his ID. I think I talked about all the tables. The table temperature is quite the same as power, but instead of power, of course, it's temperature. Then about flexibility of the database, it's not very flexible because the database is created under PostgreSQL, so it's quite in SQL the tables are really strict. You can't add information, you have to follow the rules of the table, so it's not very flexible. If a company of a group of users want to add some data or anything, they have to ask an admin, which has to change the database itself. So it's not very flexible. Then about scalability, it should be flexible because the between the relations between the stations and the reports and the users and the other tables, users can access all their data, and a lot of users can upload their data in the database and still can access it with the foreign keys and primary keys. But the problem is if there are a really large amount of users or of weather stations, there will be a problem of too much queries arriving to the database, so it's not implemented in that version. But what we could thought is add another server which can store all the data 24 hours old, so it can clear the database every day and allow it to store data all the time. But it's not implemented here by lack of time. Then about backup, I imagined some ways to backup the database like every day. I created a file named PostgreSQL backup.bat, which is a bat file, a small program which is doing a dump of the database and taking the month, the day, and the year, putting it in the name of the final file. So you can have like a backup file for every day, which is very useful if you want to take your database again, if you have any problem or anything. And what I found to launch that small program every day is the Windows Task Planifier. So here, as you can see, there is a task named backup, which is launching at 2 p.m. every day, which is taking the PostgreSQL backup.bat and launching it automatically. So this file will be launched every day and doing a backup of the database every day also. So that was how I imagined backup for that database. Then, as you can see here, I created some index to fast to make the queries faster, because with a large amount of data, it's really beginning to be slow your if your query is checking the whole table. It could be very long. So I created several index about especially date, as you can see here, date, about the table power, reports, and temperature. Then I created also an index about power and temperature in the tables power and temperature. I don't I didn't do data analysis of the other data, so I don't know which one is very useful, which one is the most important, but could be interesting to add some index to those two if you do a data analysis, and then you can know. Mm, as you can see, the name of the index are very simple. It's the name of the field following by the name of the table, so you can easily know which index is it. All the index are binary trees index. I think it's the more useful for that database in that case. Then I'm gonna talk a little bit about some queries that I imagined to interact with the database. Here you can see these are all select queries interacting with date, and for some of them power or temperature. Here, for example, it's taking all the data of the table power for the user number one, as you can see here, and taking all the records between two different hours, like 11 p.m. and 11:30. Then here it's finding all the data where the power is above 100 watts for the first user. The ID user is corresponding to the table users. Then the same in the temperature, the same with the date, and with a special temperature like above 29 degrees or above or below, 6 degrees. And then finally select all the data from the reports, the station, the weather stations, the reports, where date is around two two special dates. If you do that queries, you obviously have to select a whole date like year, month, day, and hour, minute, second, or anyway it will not work. It's the only way to do it with this kind of queries. So that's all. I talked about everything. Thank you very much and see you soon.